Good day, everybody. So, acid base we're going to talk about today, and we've all had those questions where we get the person who's either got a needle stuck in their arm, or have been in a motorbike accident, or they're diabetic, all that sort of thing, and something's gone wrong with them. They're not breathing, or they're non-responsive, or so on, and you check their blood gas and you get all this information with regards their acid base status. Three things we're interested in. The first thing is pH. pH is the first thing you look for. So what do we say? If the pH is in the range between 7.35 to 7.45 in general, some will go even tighter and say 7.38 to 7.42, but within that range, that is a normal acid-base status. Now, unless it's a tricky question, we don't have to worry about it. So, for example, you could look at this and say, okay, there is no acid-base imbalance. And there isn't, because you're on neither side. You're within the normal parameters for pH. However, it may be a bit of a tricky one where you've had full compensation, and that full compensation has brought everything back to normal. But you can look at the question and work out from there where it is. So, what, however, if it's not within these normal parameters? If the pH is less than 7.35, so less than 7.35, then you know that you have acidosis. So look at the pH first. If it's below 7.35, acidosis. If you look at it and it's greater than 7.45, then what do you have? Then you have alkalosis. Alkalosis, no doubt at all. Alkalosis. So that's the first step. pH greater than 7.45, alkalosis. Less than 7.35, acidosis. Bingo. So we know from that. Then, what are the other two things we have to decide? We have to find out, is it a respiratory problem, or is it a metabolic problem? Now, I'm going to put this in red because it's really important, because if it's a respiratory problem, we're looking at changes in the partial pressure of carbon dioxide. If it's a metabolic problem, it's to do with bicarbonate ion concentration. So let's have a look at this. Let's look at respiratory first. You look at the respiratory and you see, is PCO2 within normal parameters? And usually the normal parameters for PCO2 are between 35 and 45 millimeters of mercury. If PCO2 is less than 35, less than 35 means you've blown CO2 off, rapid breathing, you've said to undergone respiratory alkalosis. Respiratory alkalosis. And if it's greater than 45, basically what you're doing is you're holding CO2 within your body, you're increasing levels of CO2, then you have what we call respiratory acidosis. Now, if either of these values match the pH, so for example, if your pH is less than 7.35 and your PCO2 is greater than 45, bang, you have got respiratory acidosis. Easy. Also, you look at that, you could look at CO2 and you see no changes at all, so you think, oh, well, that's not a problem there, so what do we have to look at? Let's look at metabolic. Is it a metabolic problem? And here we look at bicarbonate ion levels. Now, bicarbonate ion levels should be around 24. A lot of people work in the range of 22 to 26 being normal. Some will even say 28. It's going to change, so don't worry too much about that. But if your bicarbonate ion levels are less than 22, so if they're much lower, that is going to be an indicator of metabolic acidosis. And why is that? Well, high levels of hydrogen ions being produced are going to suck up all those bicarbonate buffers, so you're going to use more and more bicarbonate, you won't be able to produce enough, and your bicarbonate levels drop, so therefore bicarbonate concentration drops. So less than 22, metabolic acidosis. Conversely, if it's greater than 26, so therefore you've got more bicarbonate than you need, if not surprisingly, bicarbonate being a base, metabolic alkalosis will be the problem. So again, you match this to the pH. So for example, again, if the pH is less than 7.35 and your bicarbonate levels are down at say 10 millimolar, bingo, you must have metabolic acidosis. There it is. In a nutshell, very simple how to do those basic pH acid-base problems.